Okay, in order to solve the following log equation, log base 2 of 3x plus 2 equals 5, my first step is to isolate for the logarithm. Looking at this, we notice that the logarithm is all by itself. So we convert this to the exponential form. We have 2 to the power of 5 is equal to 3x plus 2. We then simplify this further. 2 to the 5th power will give us positive 32 is equal to 3x plus 2. We will then isolate for the variable x by subtracting 2 on both sides. This will leave us with positive 30 is equal to 3x. We will then divide both sides by 3. And this will leave us with the final solution of x is equal to positive 10. Let's go ahead and box that in. Moving on to question number 2. For question 2, we have to solve for log base 3 of 2x plus 9 equals 3. My first step is to isolate for the logarithm. In this case scenario, there is nothing next to the logarithm. It's already isolated by itself, so we can convert this to the exponential form. Hence, I have 3 to the power of 3 is equal to 2x plus 9. I will then simplify this further. 3 to the 3rd power will give me positive 27, which is equal to 2x plus 9. I will then subtract 9 on both sides. Minus 9, minus 9. This will leave me with positive 18 is equal to 2x. I will then divide both sides by 2. And this will leave me with a final solution of 9 is equal to x, or essentially x is equal to 9. From there, let's move on to question number 3. For question 3, we notice that the logarithm is already isolated by itself, so we convert this to the exponential form. We have 2 to the power of x minus 5 is equal to 64. We then notice that we have an exponential equation. I will then rewrite this to be with a common base. In this case, let's go with the common base of 2. So we have 2 to the power of x minus 5 remains the same, but we can convert 64 to be 2 to the power of 6. Once the bases are the same, we can set the exponents to be equal to each other. Hence, we have x minus 5 is equal to positive 6. We will then isolate for the variable x by adding 5 on both sides. This will leave us with x is equal to positive 11 as the final solution. Moving on to question number 4, we have the following log equation. My first step is to convert this to the exponential form. I have 10 to the power of x plus 1 is equal to 100. I will then convert this with a common base of 10. So we have 10 to the power of x plus 1 remains the same, and 100 can be rewritten as 10 to the 2nd power. From there, we notice that the bases are the same, hence we can set the exponents to be equal to each other. From there, we then isolate for x by subtracting 1 on both sides. This will leave us with x is equal to positive 1. Moving on to question number 5, we have the following log equation. My first step is to convert this to the exponential form. Hence, I have 2 to the power of x is equal to 128. I will then convert this with a common base of 2. So I have 2 to the power of x remains the same, but I can rewrite 128 to be 2 to the power of 7. From there, I notice that the bases are the same, hence I can set the exponents equal to each other. So I have x equals 7 as the final solution. Moving on to question number 6, we have the following log equation. My first step is to convert this to the exponential form. I have 4 to the power of x is equal to 256. I will then convert this with a common base of 4. Now, if 4 doesn't work out, you can always try out something smaller, like a 2. So I have 4 to the power of x is equal to 256 can be rewritten as 4 to the power of 4. From there, we then notice that the bases are the same, so we can set the exponents to be equal to each other. So x equals 4. From there, moving on to question number 7. This one, we have to apply the power rule of logarithms. Why is that the case? Well, if you ever have an exponent, you have to move it to the front. So this will turn into 2 times log base 2 of x minus 1 is equal to 6. From there, we will then isolate for the logarithm. We notice that if we ever have a number next to a log expression, it is multiplication. So we do the opposite. We divide both sides by 2. This will leave me with the following on the left-hand side. The 2's cancel out. I'm left with log base 2 of x minus 1 is equal to 6 divided by 2 will give me 3. We then convert this to the exponential form. I have 2 to the power of 3 is equal to x minus 1. We then simplify further. This will turn into what? 2 to the third gives us positive 8, which is equal to x minus 1. We then isolate for the variable x by adding 1 on both sides. This will leave us with 9 equals x, or essentially x is equal to 9. Moving on to question number 8. For number 8, we have the following log equation. My first step is to take this exponent, this power, and move it to the front using the power rule. So this will turn into positive 2 times log base 5 of x plus 4 is equal to 4. I will then isolate for the logarithm by dividing both sides by 2. On the left-hand side, the 2's cancel out, and I'm left with log base 5 of x plus 4 is equal to 4 divided by 2, which will give me 2. And then I convert this to the exponential form. I have 5 to the second power is equal to x plus 4. We know that 5 to the second power will go ahead and leave us with 25 is equal to x plus 4. We then isolate for the variable x by subtracting 4 on both sides. This will leave us with 21 is equal to x, or essentially x is equal to 21. Moving on to question number 9. For number 9, my first step is to convert this to the exponential form. So I have 3 to the power of 2x plus 1 is equal to 243. We then convert this with a common base of 3. So we have 3 to the power of 2x plus 1. 243 can be rewritten as 3 to the 5th power. We then notice that the bases are the same, so we can set the exponents to be equal to each other. 2x plus 1 is equal to 5. We then isolate for x by subtracting 1 on both sides. This will leave us with 2x is equal to positive 4. We then divide both sides by 2, and this will leave us with x is equal to positive 2 as the final solution. Moved on to question number 10. For number 10, my first step is to convert this to the exponential form. So I have 2 to the power of 3x minus 1 is equal to 32. My next step is to convert this with a common base of 2. So we have 2 to the power of 3x minus 1 remains the same. And we can convert 32 to be 2 to the 5th power. We then notice that the bases are the same, so we can set the exponents equal to each other. 3x minus 1 is equal to 5. We then isolate for the variable x by adding 1 on both sides. This will leave us with 3x is equal to positive 6. We then divide both sides by 3. And this will leave us with a final solution of x is equal to positive 2. Moving on to the next question, we have the following. My first step is to convert this to the exponential form. We have 2 to the 5th power is equal to x. Or essentially, we have what? 32 is equal to x. Or x equals 32. Let's go ahead and box that in. Moving on to question number 12. For number 12, we have the following. We convert this to the exponential form. We have 5 to the 3rd power is equal to x. We then isolate for x. So we have what? 5 to the 3rd gives us 125, which is equal to x. Or essentially, x is equal to 125. Moving on to question number 13, we have the following. We have log base 4 of x minus 3 is equal to negative 2. My first step is to convert this to the exponential form. I have 4 to the power of negative 2 is equal to x minus 3. We then convert the 4 to the negative 1 to be 1 over 4 to the 2nd, which is equal to x minus 3. And 1/4 to the 2nd will leave us with 1 over 16, which is equal to x minus 3. We then add 3 on both sides. And this will leave us with the following. This will be a decimal. So we have, let me calculate that real quick. Okay, this will give us 3.0625 is equal to x, or essentially x is equal to 3.0625. If you want to convert this to a fraction, you're more than welcome to convert it to a fraction, your choice. Let's move on to question number 14. For number 14, my first step is to convert this to the exponential form. I have 4 to the 2nd is equal to 4x plus 4. We then convert the 4 to the 2nd, and that will turn into 16 is equal to 4x plus 4. We then subtract 4 on both sides, minus 4, minus 4. This will give us positive 12 is equal to 4x. Then we divide both sides by 4. This will leave us with 3 is equal to x, or essentially x equals 3 as the final solution. Moving on to question number 15. For number 15, my first step is to convert this to the exponential form. I have 5 to the 3rd is equal to 5x. Or essentially, I have 125 is equal to 5x. We then divide both sides by 5. And this will leave us with 25 is equal to x. Or essentially x equals 25. Moving on to question number 16, we have the following log equation. My first step is to convert this to the exponential form. I have 4 squared is equal to 1/2 x. We then simplify this further. This will turn into 16 is equal to 1/2 x. We then multiply both sides by the denominator. You always multiply by the denominator. Now, don't get me wrong. You can definitely divide both sides by 1/2 or multiply both sides by the reciprocal. You can definitely do so. But this is my recommendation, especially as you go to the upper level math courses. Okay, so we multiply both sides by 2. On the left-hand side, this will turn into a 32. On the right-hand side, the 2's cancel out. We have 1 times x, which is just simply x. Or essentially, we have x equals 32 as the final solution. Moving on to number 17, we have the following log equation. Notice that we have 6 in front of the logarithm, which means what? Multiplication. So in order to get rid of it, we divide both sides by 6. This will leave us with what? On the left-hand side, the 6's cancel out. I'm left with log base 2 of 7x minus 6 is equal to positive 6. We then convert this to the exponential form. We have 2 to the power of 6 is equal to 7x minus 6. 2 to the power of 6 will go ahead and turn into positive 64, which is equal to 7x minus 6. We then isolate for the variable x by adding 6 on both sides. This will give us positive 70. is equal to 7x. We then divide both sides by 7, and that will go ahead and give us 10 is equal to x, or essentially x equals 10. Moving on to question number 18. For number 18, we have the following log equation. Keep in mind that if you ever have a number in front of the logarithm, it is multiplication. So we do the opposite of that. We divide both sides by 9. From there, we then, on the left-hand side, the 9's cancel out. We're left with log base 2 of 6x plus 2, which is equal to 27 divided by 9. Okay, and that's going to give us positive 3. We then convert this to the exponential form. We have 2 to the power of 3 is equal to 6x plus 2. We know that 2 to the third power will go ahead and give us positive 8, which is equal to 6x plus 2. We then subtract 2 on both sides. This will leave us with 6 is equal to 6x. We then divide both sides by 6, and this will give us a final solution of 1 equals x, or essentially x equals 1.